Kerberos is a network authentication mechanism used in Windows Active Directory domains and some Unix environments known as zones. It was originally developed at MIT, Massachusetts Institute of Technology, for Unix systems, and later published as a request for comment, or RFC. Kerberos provides mutual authentication that can help prevent man-in-the-middle attacks and uses tickets to help prevent replay attacks. Kerberos has several requirements in order to function properly. These include ticket issuance method used for authentication. The Key Distribution Center, KDC, uses a complex process for issuing ticket grant tickets, or TGTs, and other tickets. The KDC, or TGT server, packs user credentials in a ticket. Tickets provide authentication for users when they access resources such as files on a file server. These tickets are sometimes referred to as tokens, but they are logical tokens, not a keychain-type token previously discussed in the section Something You Have. Time synchronization. Kerberos version 5 requires all systems to be synchronized within 5 minutes, one after the other. The clock that provides time synchronization is used to timestamp tickets and ensures that these tickets expire correctly. This helps prevent replay attacks. In a replay attack, a third party tries to impersonate a client after interfering with the data captured in a session. However, if an attacker gets hold of a ticket, the timestamp limits the amount of time an attacker can use that ticket. A database of topics or users. In a Microsoft environment, this is Active Directory, but can be any user database. When a user logs in with Kerberos, the KDC issues a ticket to the user, which typically has a 10-hour lifetime to be useful for a single working day. So when a user tries to access a resource, the ticket issuing ticket is presented as authentication, and the user is given a ticket for the resource. However, if users are logged in for more than 10 hours, the ticket expires. This prevents them from accessing network resources. So in this case, users may be asked to enter a password to renew their ticket, or may need to log out and log back in to create a new ticket issuing ticket. New Technology LAN Manager, or NTLM, is a suite of protocols that provide authentication, integrity, and confidentiality in Windows systems. In their simplest form, they use a message digest hash algorithm to challenge users and check their credentials. There are 3 versions of NTLM. NTLM is a simple MD4 hash of a user password. MD4 has been broken and is not recommended to use either NTLM or MD4 today. NTLM v2 is a challenge response authentication protocol. When a user tries to log in, Ntlm Lv2 creates an HMAC MD5 hash that is a combination of username, login domain name or computer name, user password, current time, and more. To generate an HMAC MD5 message, the authentication code starts as an MD5 hash of a user's password and is then encrypted. NTLM2 session improves NTLM v2 by adding mutual authentication. In other words, the client authenticates with the server, and the server authenticates with the client. So, which protocol should you choose? In fact, Microsoft strongly recommends that developers do not choose one of these protocols. Instead, developers should use the Negotiate security suite among themselves. This security suite chooses the most secure security protocols available among systems. If available, it tries to use Kerberos first. If not, It uses Ntlm v2 or Ntlm 2 session, depending on the capabilities of the systems involved in the session. Lightweight Directory Access Protocol, LDAP, specifies formats and methods for querying directories. In this context, a directory is a database of objects that provides a central access point to manage users, computers, and other directory objects. LDAP is an extension of the X500 standard, heavily used by Novell and early Microsoft Exchange Server versions. Window domains use Active Directory, which is based on LDAP. Active Directory is a directory of objects, such as users, computers, and groups, and provides a single location for object management. Queries to Active Directory use the LDAP format. Similarly, Unix regions use LDAP to define objects. Administrators often use LDAP in scripts, but they should have a basic understanding of how to define objects. For example, in the user's container in the google.com domain, a user named Jack is identified with the following LDAP string: LDAP : / CN equals Jack, CN equals users, DC equals get certified get ahead, DC equals com. CN equals Jack. CN is the abbreviation of the common name. CN equals users. CN is sometimes referred to as a container in this context. DC equals get certified get ahead. DC is short for domain component. DC equals com. This is the second domain component in the domain name. LDAP Secure, LDAPs, uses encryption to protect LDAP transmissions. When a client connects to a server using LDAPs, the two systems establish a Transport Layer Security or TLS session before transmitting any data. TLS encrypts data before transmission.